This is very interesting property which says that the definite integral from a to b of f of x, yeah, we have to have with respect to x, is the same as the definite integral from a to b of f of a plus b minus x. So this is kind of a composite function where you have f of something, where that something is in turn a function of x. So yeah, let's try to prove it. We can simplify the left hand side. This left hand side simply, from definition, it comes out to be g of b minus g of a. For the right hand side, what I'll do is, for the right hand side, since I have a composite function, I can do something called u substitution. So what I'll do is I'll substitute u is equals to the inside function. So this inside function becomes a plus b minus x. I'll call it u. And whenever we do u substitution, it is always suggested that you find the differential of u. So du, in this case, it will be nothing but the derivative of this with respect to x is 0, 0, and the derivative of this with respect to x is negative 1. So the differential becomes negative dx, and this is useful because we can incorporate this negative dx in our integration somehow. Another thing that we require when we are doing definite integrals, we need to look at the limits as well. So when we have x is equals to the lower limit a, what happens to our substitution? What does u become? Uh, if you see carefully that if x is equals to a, if you plug in a, this becomes an a plus b minus a. So u is equals to b. And similarly, if you put x is equals to the upper limit, that is b, what does a u become? If you plug in a b here, it becomes a plus b minus b. So u becomes just a. So what I can do is I can write the right hand side. So let me name it RHS. My right hand side integral, it becomes the definite integral. Let me write it over here. Now the older lower limit was a, but then now the lower limit will become b. The older lower upper limit was b, now it will become a, and this becomes f of u because we just substituted that inside function as u. And instead of dx, I need a du, but you realize that du is same as negative dx, so I can rewrite this as negative du is equals to dx. So I'll have a negative du, and what I'll do is I'll put the negative out front because it is just a scalar. So this is du. And now this is a plain old definite integral, because if I just look at the inside function, I disregard this negative sign. So if I just look at this, it becomes the definite integral from b to a of f of u with respect to u. According to our assumption, I'll put it over here. The negative out front, of course, don't forget the negative. It is g of the upper limit, which is a, minus g of the lower limit, b. And of course the whole thing goes in a bracket because there's a negative out front. And it is very evident that if you simplify this, it becomes a negative of negative gb. So it becomes g of b and minus g of a, which is what we simplified the left hand side to be. So we can say that this side is equal to this side, and hence we have proved this property. A very interesting property to look at.